So, transpose of a matrix is uh, when a matrix or a matrix that is formed by interchanging the rows into column or the columns into rows is a transpose of that particular matrix, and it is denoted by transpose of A is A to the power T or A dashed. Okay, now suppose A is A, B, C, D, then A transpose become, if you change this row into column, so it become A and C, and if you change this row into column, then it become B and D. So the reduced matrix will look like this. It is a 2 by 2 matrix. Suppose there is a rectangular matrix. Suppose A is A, B, C, D, E, F. So here A transpose become, first this row become the column, so it will be A, B, C, then this row become the column and it will be D, E, F. Okay, now there are some properties of this or some okay, so now if we take minus A transpose, it will become minus A transpose. Okay, number one. If we take plus or minus, then taking the transpose, it will split, just split. And number three, but if it is in the multiplication form, then B comes first, then okay, these are some important properties here in the transpose. Okay, now there are some important portions also, that symmetric and skew symmetric matrix. Symmetric matrix, if you have an matrix and you take its transpose, now if it equals to A, then A is symmetric matrix. Suppose we have A is 1, 2, 2, 2, 1. Okay, now if you take its transpose, what become, first this column become row, so it will be 1, 2, then this become the row, it will be 2, 1. Now look, they are equal, so here it is a symmetric matrix. And also skew symmetric matrix, skew symmetric matrix. In that case, if you take transpose of that matrix, and if you got same matrix but with negative sign, then it is a skew symmetric matrix, negative sign, remember this. Now suppose we have a matrix 0, 5, minus 5, 0. Now take its transpose, what it become, First this row become the column, so it will be 0 minus 5. Now this row become 5 0. Now if you take minus common from this matrix, it will become, if we take minus common, that means minus comes from each of the element, so it becomes 0, it become minus 5, it is 5, and it is again 0. Now look, they are same, that means it become minus a. So here this matrix is a skew symmetric matrix. Okay, now the last part of this transpose portion is any matrix can be represented as the sum of two symmetric and skew symmetric matrices. Now look, A can be written as half of A plus A transpose plus half of A minus A transpose. Look, if you calculate this one, A transpose get cancelled and half A give you A. That means the calculation is okay. Now we have to check which one is symmetric and which one is skew symmetric. Now for this matrix A plus A transpose, if you take the transpose here, now we know by the property that transpose will be distributed if it is plus or minus. Okay, so it will be A transpose plus A transposes transpose. Okay, now here we miss one thing, that if you take the transpose of a matrix, transpose matrix, it becomes the same matrix again. Okay, so here it become A transpose plus A, that means they are same, that means A plus A transpose is a symmetric matrix. Now what about A minus A transpose? Let's see, same process, it will be A transpose minus A transposes transpose, that means it becomes A transpose minus A, that means if you take minus common, it will be A minus A transpose, that means it satisfies the property of skew symmetric matrix, that means A minus A transpose is a skew symmetric matrix. So a matrix can be represented as a summation of symmetric and as well as a skew symmetric matrix. Okay, this is the portion, the transpose portion ends. Okay, read it carefully.